For today's lesson, we are going to be looking at percent proportions. So a percent proportion is only used when you are using, you guessed it, percentages to compare numbers. So we've used regular proportions where we're just comparing two different units. For percent proportions, there's going to specifically be either the word percent or percent sign. So we have two ratios that we are comparing just like we do in proportions. The first ratio compares part of a quantity to the whole quantity. So part to the whole. The second ratio is the equivalent percent out of 100. So what does the percent proportion look like? We've got a couple examples and some explanations here. There are four parts: the part, the whole, the percent, and 100. You will notice that every single time we always have 100 at the bottom right because percent is always out of 100. So the part is part of the whole. So like in a pizza, the slice of pizza is part of it. The whole is the whole entire thing, so the whole entire pizza. One thing to note is the part is before or after the word is, usually. The whole is always after the word of. And then we have our percent, which is going to be the word or followed by the percent sign, and then 100. And there's some other pictures down here that help kind of explain it. So my recommendation when we are doing problems is the first thing, I'm going to write this on the side, that I do is I write 100. So in my blank proportion, which we've got set up here, I know automatically my proportion's always going to have 100 in the bottom right. So let's look at this problem. 18 is 75% of what number? So the second thing that I always look for is I'm going to circle the percent. So either the percent sign or the percent word. If we look at this, we have the percent sign. So it says 75%. In our percent proportion, the percent always goes above 100. The third thing that I always look for is the word of, which equals the whole. So the word after the word of. And if we look at this, I'm going to highlight. So I'm going to highlight it here. And I see the word of, and what follows is what number. Since it doesn't say a number, that means we don't know it. That means we are solving for it. So that is our unknown. And then the fourth thing that I look for is the part, which in this case is just going to be whatever that other number is. 18 is clues us into the part. So if it helps you to use that, is over of equals the percent out of 100. And just know for this lesson, we are always going to be solving for the whole. So now we've got a proportion that we can solve. So I'm going to multiply 18 and 100, which equals 1800. And the number I divide by is the number in the same diagonal as the variable, which is 75. And I will get 24. Let's try another. Using the same steps. Write 100, circle the percent, highlight the whole, and then find the part. So our problem is 5% of what number is 75. We're just going to say 75, not 75.4. Again, first step, write 100. Second step, circle the percent. I see the percent sign right there. That always goes above the 100. Third part, we're going to highlight the whole. So what comes after the word of? It says of what number. That means it's our unknown. It's our variable. The whole goes on the bottom. And then the last part, circling the part, So is 75, 75 is our part. Now we've got a proportion we can solve. So I'm going to multiply 75 times 100. Since that's in the same diagonal together, we get 7,500. Divide by the number that's in the same diagonal as the variable, which is 5. And we get 1,500. We're going to do one more that's just kind of a basic problem like that, and then get into some word problems. So 125 is 60% of what number? So first step, plug in 100. Second step, circle the percent, so 60%. Third step, highlight what comes after the word of what number? Because that's talking about our whole. That means that is our unknown. That goes on the bottom left. And then circle the part. 125 is. Now we've got our proportion that we can solve. Okay, I'm going to multiply 125 and 100 because those are the two in the same diagonal, which equals 12,500. And I'm dividing by the number that's in the same diagonal as the variable, so dividing by 60. And when I do that, so 12500 divided by 60, I get 208.33333 and so on. I'm just going to round to 208.3. All right, so those were just basic percent problems. Now let's look at some word problems. So it's going to be almost the same process, just you got to pay a little bit extra close attention to the whole. So at Hogwarts, 270 students ride their broom to school. If this number is 72% of the entire school, then how many students go to Hawthorne? So first step, writing 100. The second step still is to circle the percent. I see the percent sign, 72%. Now I'm looking for the whole. Sometimes it's going to be after the word of, but in a word problem it's hard because the word of might be anywhere. So when I'm thinking about the whole, I'm looking for the total. What is referencing the total? And if we look at the question, it's saying, how many students go to Hogwarts? So what two things are we comparing? The total is the total students, and the other part is 270 students ride their broom to school. That's not all the students, that's some of the students. So broom riders is how I'm going to label that. So this other number, 270, is talking about the broom riders, which is part of the whole. And then the question, how many students go to Hogwarts, that's asking how much total. That's asking what our whole value is. Then I'm going to highlight my diagonals. And we're going to solve. So the two numbers I'm going to multiply are 270 times 100, which is 27,000, and dividing by the number that's in the same diagonal as the variable, so dividing by 72, which gives me 375. Since this was a word problem, we're going to include units. So what was this variable referencing? The total students. So 375 total students. Okay, number 5. Jasmine filled up 12 bags of leaves after raking 40% of the yard. How many bags will she need to rake the whole yard? So what two things are we, well, first we can do, just as we've been doing, write 100 and then circle our percent. So 40% always goes about the 100. Next thing I want to look at is just what two things are we comparing. So we're comparing the bags that she raked to the total amount of bags that she needs. So total bags is our whole, that goes on the bottom. And then bags filled, that's part of it. She hasn't filled all of them, she's only filled some of them. So when we're looking for the whole, is the 12 bags talking about the whole, or is it asking how many bags will she need to rake the whole yard? This question here is asking us what the total is. We don't know the total. So the other number that's given to us, that 12, is telling us our part. 12 bags have been pulled. And then the last one here. 95% of the ducks in the pond were swimming. If 57% of the ducks were swimming, how many were in the pond? So, first step, 100. Second step, find that percent and put it over 100. Now let's think about what are the two units we're comparing. So we're comparing the ducks that were swimming. Whoopsies. This should be 95. Let's say 95 ducks were in the pond were swimming. Sorry, that shouldn't be percent. That's confusing. 95 ducks were in the pond were swimming. If 57% of the ducks were swimming, how many were in the pond? So we're looking at, what are we comparing? We're comparing to ducks. We're comparing ducks swimming to total ducks. So let's think about, what is the question asking us? How many were in the pond? Plus, what is that other number telling us? So 95 ducks were swimming. Is that some of the ducks or all of the ducks? Only some of them were swimming, so that is our part, which means we're solving for the whole. How many were in the pond? We don't know how many total. That's what we're solving for. So I'm going to solve. I'm going to multiply 95 times 100, which equals 9,500. And I'm dividing by the number that's in the same diagonal. Nope, that's the wrong one. The number that's in the same diagonal as the variable is 57. So 9,500 is 166.7. So let's say that's about 167 ducks.